areas, and that's basically the practical application of geometry. But geometry actually itself is it's really um, more than just those practical applications. And so when you study, um, like say, you like science, right?
Right?
Okay. Now, science, there are two kinds of sciences. One is called pure science or pure sciences. So that means we are not really bothered about applications, practical use. It's just purely for the sake of knowledge to know something more. Good.
Good.
So math actually is considered part of the um, pure science,
And then
and
the other one is pure sciences.
other one's called applied sciences. So applied sciences, all the engineering is part of that engineering, like electrical engineering or computer engineering and all that. Just like when you apply that into practical applications. Good.
Good.
And even though when we started pure science, we're looking really just for the to get more knowledge, but the knowledge we gain and eventually we'll find application in the real world. Okay.
Okay.
For example, math. What would actually math, um, and physics and chemistry. So those are considered pure sciences. Then we have applied math, applied physics, applied chemistry. Okay. So
Okay.
engineering is both pretty much applied physics or and chemistry. Um, so for example, the imaginary number. Have you learned about that?
I think we talked about it a bit in pre-algebra when we were doing
Right.
different types of numbers.
So we have this peculiar number called square root of -1, and we call it imaginary number because we don't see that in real world. In the real world, the number we're dealing with, we call that real numbers. So real numbers we have, of course, we have integers and also have rational numbers, and we have irrational numbers. Okay, and the rational and irrational number together is called real numbers. And those when they first find this, it's just kind of curiosity of what if we have if x squared equal to -1, does this one have a solution? So
So what would the square root of -1 be then?
yep, so that will be I. That's what we use. I
So
is
why
defined.
is it I then?
I just a symbol. It's just like we use an I to denote the square root of -1. So it'd be a lot easier to write later on. We don't have to keep
Does it
writing square
does
root
it
of
stand for
-1.
anything?
What's that?
Does I stand for anything or
Uh, I just means imaginary number
okay?
from this one. Good.
Good.
Yeah. So like in math, we like to use symbols, especially algebra, so because that makes things a lot easier. And for a while, nobody knows what going to use this for. But later on, well, they find that we can use that to study physical phenomena, especially semiconductors. And so semiconductors, uh, without semiconductors, we won't have today's computers or smartphones or all kind of things.
Square root of -1 the only imaginary number?
Or it could have other magic number like square root of -9, but we can write as 3 times I.
Okay.
Good.
Good.
Yeah. So we could have many infinite number of imaginary numbers, but instead we keep writing -1. We just use I. So that saves a lot of time.
So would any square root of a negative number be an imaginary number?
Yes, any square root of negative number is an imaginary number.
Okay.
So this will be 4i. So basically we write this one as -1 times square root of 16. Now square root of 16 is 4, so we just write that as 4i. Okay?
Good.
Okay. So now we come down to our uh, geometry. At first, it actually is a pure math, but it also have its application. One of applications is when we're trying to measure areas, which is pretty useful in real life because especially back then, if you are a farmer, you want to know how big is your field, right?
Right.
And also, if you are a builder, you want to build a house, then you want to know how big the house there is. Okay?
Okay.
So when you're talking about measurement, you're always talking about a unit because without unit, there's no measurement. So
Like
go ahead.
so units are like inches,
Yeah,
feet,
inches,
meters.
feet, and also we have meters, and we have pound in this country, but every ounce is a kilogram, right? Like that. And of course, we have like a gallon, right?
Right.
We have like mm, pint, things like that. That's all units. Knowing the units, then we'll be able to do a measurement. Now, in terms of measure area, the unit we got is called unit square. So it's a square which this side, both all sides are one. It can be 1 feet, or it could be 1 meter, or 1 inch. No matter what, it is one. So one times one is one. So this is called the unit square. Good.
Good.
So everything in measurement is we are going to see how many of those unit squares are there. So therefore, when you measuring a square, which is say 4 by 4,
So it'd be
okay,
16 unit squares. Units.
right? Yeah, the reason we do 4 times 4 is because if we look at how many unit squares there are, we get 16 of those, right?
Right.
So that's why we use uh, length times width. Good.
Good.
So that's where first of all we have this formula, length times width, and sometimes we call it base and height. So we call this is a base and this is height.
Right.
So
When
we
we're
can
measuring like 3D,
what's that?
like when we're measuring 3D, instead of using length times width, sometimes we use base times height.
Right. Then when we measure the volume, we actually have the height. But in terms of area, sometimes we use length and width. Sometimes we use base and height. And base height is more general. Uh, and because when we go to different shapes, you'll see why we use base and height. Uh, okay, so that's area. That's for square. Square is super easy. But this formula actually is for the rectangle. So we have base times height. Good.
Good.
Now, from there, we can say what happens if we have other shapes like parallelogram. So now, in order to measure the area of parallelogram, we're going to change that into a rectangle because we know how big a rectangle is, right?
Right.
Now, if we have a parallelogram, which means the two side here are parallel, and the other two side parallel. So we call this one the base. And now the height actually is the length from the top line to the bottom line, which has 90 degrees here. Good?
Because the other if we did use one of the other slides going up, that wouldn't be height because it's just it's angled. So
Mm-hmm. Right. So the height is always 90 degrees from the base. Good?
good.
So it's basically the shortest distance between the two lines. Uh, okay. So now the area for parallelogram is still base time height. And the reason we can do that is because we can use something called scissor congruency. That means you can use scissor to cut it and make that into a different shape. As long as they are congruent, then we uh, we have the same area. So let's look at that. Why is that so true? If we do something like this, cut like that, then we put this side, we take this and move on the right hand side. We'll get something like this. And now we'll get exactly a rectangle, right?
Right,
And this rectangle, the area of this rectangle then will be the base times height, right?
right. Does this only work for parallelograms?
This one only works parallelogram.
Okay.
So now we have another shape. It's called the trapezoid. Trapezoid has kind of like parallelogram, but they only have two sides are parallel. The other two sides are not parallel. The other two sides could be anything. Okay,
Okay.
so that's called trapezoid, and it has two bases. One is on the bottom, and one is on the top. So we say this is base one, this is base two, and if you look at parallelogram, we also have two bases, but in this case,
Well,
uh, the both bases are the same
yeah,
length. Yeah, good.
good.
Okay, so now what we can do is uh, we can make this exactly the same copy of this and turn that upside down, and we are going to get actually a trapezoid. Okay, we good here.
Yeah.
So now we know this here is
Your connection is
base
kind
one.
of your connection is going a little bit in and out.
Oh, okay. Uh, okay. Are you okay now?
Yeah.
Okay. So now you see that we got two trapezoid, right?
Right.
And when we put them side by side, we got another uh, parallelogram. And the formula for parallelogram we know is base times height, right?
Right.
Okay. So therefore, for this parallelogram, the area is b sub 1 plus b sub 2 times height, right?
Yeah. What do you mean by like B sub?
That means b sub 1 is the way we write. This is a base 1. This is a base 2. So in math, we put a subscript just under the letter.
Okay.
Okay, so basically we say there's two bases. They are different size. So if we get parallelogram, we measure one base, then we measure the other base, we just add them together. Okay?
Okay.
And and if we times height, that's the area of the whole parallelogram, right?
Right.
But the trapezoid is only half of that, right?
Right.
That's why we write half times that. So this is the area formula for trapezoid. Good.
Good.
So now we're going to looking at a triangle. So we
Triangle.
pretty much now. Go ahead.
So triangle is basically base times height and then divide by two.
Right. And but the reason for that is this. Remember, we
So
eventually will
triangle
get
is like half a rectangle
what's that?
because a triangle is basically just half of a rectangle.
Uh, actually, is half a parallelogram.
Yeah.
Okay. It's not always be half of a rectangle. For the right triangle, yes, but for the other kind of triangle, what we got is actually a parallelogram. Okay, so this is the base. Remember, the height is from the tip to the bottom to the base of 90 degrees. This is the height. Okay,
Good.
so we do the same thing as we're doing with the trapezoid. We basically make the same copy, but turn that upside down. Then we got something like that. Okay,
Good.
exactly the same copy. So that's you have the same area. So now we ends up with a parallelogram, and parallelogram we know is base times height, right?
Right.
But the triangle here just half of that. So we got the area then is half of that. Good.
Good.
Okay, so now you know all the formulas. You know the square, you know the parallelogram, rectangle, and the trapezoid, and all the triangle. Good.
Good.
Now parameter actually is pretty easy. Parameter you just add all the sides together. Good.
Good.
So when you have say a trapezoid, you got base one here, base two here, but you need to know this length.
Yeah, the other two sides.
You have to know this side. So the parameter then, say this side is, let's say this is A1 and this A sub 2, just like A sub 1 plus A sub 2 plus B sub 1 plus B sub 2. Good?
Good.
We just all that. And then now actually we are using the language is algebra. We use symbols to uh, describe the things. And that means with the symbols, then we can come up with a formula. Good?
Good. What about the area of like other shapes like circles and
Circle is different. Circle, that's something we're going to look at. Circle actually is has to do with
the radius and
radius. So the area then is pi r squared, and that's something we can learn why is that so. Yeah,
so what
mostly
would be the area for like a kite or like a diamond?
a kite is actually two triangle. So if you know the height here, this height we make this top triangle, then the bottom is another height. So this actually made the two triangles, a kite.
And then a rhombus is basically the same thing, right?
A rhombus is basically a parallelogram with all four sides are the same. So rhombus, you can use the parallelograms formula. Okay?
Good.
Yep. So knowing the basics, the then you can pretty much measure any other shape. And especially we know how to do a triangle because pretty much all uh, not all the geometric shapes, but we call it polygons. Polygons, that means we have many sides. So all those many sides, you can break that down to triangles. Once you break down triangles, then you can do some measurement.
Like we can also break like some bigger shapes like hexagons, pentagons, and
Right,
octagons.
right. Right. And that all the family is called polygons. Poly just means many. That's a Greek word. So pentagons and those are part of that. So we got triangles, then quadrilaterals, then we have all kinds
Yeah.
pentagons and all kinds of different shape, different size. Good.
Good.
So that's what we have for this time. Okay.
Okay.
I'll
Thank
s-
you.
I'll see you next time.
Bye.
Bye.